My name is Justas Brazauskas, and on behalf of my colleagues, I'll be presenting DataMoves, Entangling Data and Movement to Support Computer Science Education. So over the recent years, there's been a widespread push to popularize computer science education, focusing on digital literacy, computational thinking, and problem solving, where the end goal is often introducing programming. While learning to code is, of course, a fundamental digital literacy skill, too much emphasis on coding may result in other more abstract computational topics such as binary or logic being covered in a more cursory way, in return deterring students from becoming more interested in them. On top of that, the way such topics have been traditionally taught in schools is often perceived to be dull and boring. So here, our goal was to change this preconception. In our research, we propose a different, more embodied approach for teaching computer science concepts with a diversity of physical computing devices combined with choreographic elements. The goal is to transcend beyond the traditional physical computing education practices, where microcontrollers and sensors are used to teach sensing about the environment, the human body, or as a platform to learn coding on. We see that an alternative computer science teaching practices is to use physical computing technologies more broadly, enabling them alongside other more traditional paper-based mediums and artifacts used by teachers. So our goal was to develop and deploy a one-day workshop for teenage students aimed at teaching them about data representation and number systems in an embodied, engaging, and creative way. Throughout the design process, we worked as an interdisciplinary team comprising of academic staff, computing curriculum specialists, and a dance choreographer. The design research process took place through a series of collaborative sessions where, first of all, we ideated the pedagogical goals, then designed the devices, and finally developed the workshop structure. For the new workshop, we chose to develop an immersive digital dance experience for 12 to 14-year-olds that would enable them to explore, grasp, and apply the topics of binary, ASCII character encoding, pixels, and resolution. These concepts were chosen as teachers often mention about the difficulties teaching them and because they relate to one another, as seen on the right. The design criteria was quite straightforward. First of all, we knew that the devices had to enable group and individual interactions. Secondly, they had to enhance learning about computing concepts through discovery and experimentation. And finally, they had to afford creativity and how they can be used or adapted. You can see some of the rough sketches on the right. So we developed two devices that could be mapped onto the target learning concepts and used to explore number systems, data, choreography, and movement in a variety of ways. And these were, first of all, a tethered device in the form of a physical interactive base station, and a second device that was a wearable with the form factor of a large watch. The base station was primarily designed to be used collaboratively, whereas the wearable was intended to be worn by one person at a time. You can see in two diagrams. On the left, there's one person in front, and on the right, there are multiple people surrounding the octagon. And I have to mention, no one was actually barefoot. Devices were designed to drive a range of visualizations for creatively displaying the sensor-based output on a connected screen, which in this case was a projector. The design idea behind the base station was that it could be positioned in the middle of a room where up to 8 individuals could stand around the device, one in front of each distance sensor, and close to a connected projected display that would show the sensors reacting to students' physical movements in real time. This enabled exploration of the ASCII number system, which is based on 8 binary bits, zeros and ones, with each sensor serving as an input device for a binary bit. Meanwhile, the wearable device was designed with a 6-axis accelerometer, or an IMU, embedded in it. It provided real-time feedback in the form of dynamic visualizations that the user paints on a connected display, as a result of moving the hand or a leg that has been the wearable attached on. Having designed the devices, we had to decide specifically how they could be used to support learning about number systems and data representation. The DataMoves devices were conceived to be used intermittently throughout workshops rather than wholly driving it. This was so that the children did not fixate on the technology itself, but used it to explore the concepts they were learning. The use of pen and paper was also incorporated into learning activities for this very purpose. This format of using novel technologies followed by traditional materials was intended to support students in switching perspectives when learning and practicing the content through a range of learning modes. Here, you can see the overall structure of the workshop. To begin, the workshop started with a movement-based warm-up activity. This served as an icebreaker. Next, the students were asked to get into groups of 4. They then spent 20 minutes engaging in an open-ended exploration with the base station and the wearable, which was aimed to get them comfortable with using the 2 devices and getting an initial sense of how they work. Following these introductory tasks, the next 2.5 hours of the workshop were subdivided into 3 separate but interrelated sections about number systems and data concepts. And as I mentioned before, these were binary and binary number systems, ASCII character encoding, and pixels and resolution. For each, the key concepts were verbally explained, and the interactive tools, along with the other forms of activities, were used to help the students consolidate their understanding of the concepts. The final group activity in the workshop was an open-ended and creative one, where groups of 4 students were asked to use any of the paper-based tools used throughout the workshop, or the DataMoves devices, to demonstrate their understanding of the concepts they had been experiencing and learning about. Using a qualitative approach, we tried to understand, first of all, if and to what extent the DataMoves devices enabled collaborative learning. Secondly, whether the exploration and a sense of discovery fostered the students' learning. Thirdly, if and to what extent the DataMoves devices afforded creativity. Lastly, we wanted to understand the students' perspectives on the workshop. To answer these questions, we collected observation notes during the workshops and interviews with a subset of students and teachers after the workshops ended. Overall, the findings demonstrate how the combination of the movement-based activities with and without the DataMoves devices were successful at promoting and engaging a challenging learning experience. We observed that the devices, coupled with the visualizations, triggered much discussion amongst the students about the concepts of binary, ASCII, pixels, and resolution. Thirdly, we noticed how DataMoves promoted inclusivity. Even the students who self-reported themselves as less confident in their computing skills were found to actively contribute creating choreographies. Fourth, and most importantly, the students felt that the workshop improved their understanding of both the topics of number systems and data representation. All interviewed students reported that both the DataMove devices and the movement-based learning activities helped them understand the topics much better than they had previously. One of the main findings from the DataMoves project was to demonstrate how computer science topics that are often perceived as dull and boring to learn and teach can be made exciting and fun through a creative use of paper-based materials, physical artifacts, and embodied learning activities. The 4 main discussion points I'd like to touch today were, first of all, the outcome of the workshop and the devices was an innovative learning environment where we moved from simply covering the curriculum to eliciting more curious, creative, and collaborative ways by which to both teach and learn. Secondly, we explored new ways of learning and teaching about computer science concepts. The pervasive computing technology was viewed as a resource to be used in creative ways to deepen learning through enacting out and reflective understanding. Thirdly, we found that heterogeneous devices enabled different forms of creativity, exploration, and collaboration to take place. The wearable encouraged turn-taking, while the base station allowed the students to work in groups. Fourthly, we also discovered that technology does not always have to be the focal point, but that it can be brought to the forefront at opportune times and then placed aside while other learning activities take place. Finally, we observed how our new kind of free-flowing and open-ended and challenging workshop encouraged more active engagement from all students, not just the keen ones, eager to show their computing prowess, but also those who may have had less confidence in their computing skills or previously considered the subject to be dull, which in return opened new ways into exploring computer science.